Hi, Sportster Paul here with our fourth impression of SolidCAM. CAM, Computer-Aided Manufacturing. It's a program you take your solid model and it figures out how to make G-codes to machine it that you send to your milling machine or lathe or EDM machine, whatever you want. This has been interesting for some of the differences that now I understand a little better that SolidCAM operates on. It's very powerful. I love the simulator of it's got the SolidWorks CAM by CAMWorks and Visual Mill have a graphical simulator where colors show where it's gouged and where it's excess. BobCAD, the less expensive one, and MasterCAM, the real expensive one, have this Module Works simulator that I don't like nearly as much. So I'm getting to appreciate all that SolidCAM does. Let's go up and look at some of the quirky things at the beginning, because that's what might burn you if you don't know how to deal with it. Okay, so we've turned on in the add-ins, we've turned on SolidCAM right there. It took 3 seconds to load. Visual Cam, I'm not running. I turn them all off at startup because I want SolidWorks starting with the least baggage, and then I'll decide if I want to work on CAM that day. So we're okay here. We do File, Open. Here's one I was playing with, the Sandbox 3. This is the one we did in the third show. So I copied it down into a new directory, and I want to upgrade this to 4. Now, probably the simple way to do that is just change this file name, since the real file, the original file, is in my network storage. But let's show you what can trip you up here. So we're opening number 3. Last show's solid part. Here it is now. See, it's got this tab here, which is the SolidCAM tab. So the add-in's working. And because the add-in's working and it sees that there's been solid models made, tool paths and stuff like that made on your solid model, it's asking you, do you want to open that thing? And here's what's tricky. If you say yes right now, thinking, well, yeah, I want everything to copy over, it actually works the other way. Because SolidCAM has now got its chunk of code inside this -3 file, when you do a save as a -4, save as a copy -4, it won't let that be copied over. And SolidWorks gives a little notice, model copy failed. Oh, and then all the toolpaths are empty in the next one. What you have to know to do is not select the CAM part. Don't open anything. And the cool thing about this is if you want to have 3, 4 different CAM trials or representations or different ways to do things for different machines, you can just open new parts, right? You can open new CAM parts in the same SolidWorks part. That's kind of cool. So you cancel here. Now you do your file, save as, save as a copy and open. And all we're going to do is make this a 4. You can see the older file date, right? Today's the 8th. Yesterday was the 6th. So we say save. Now it's upgrading that, changing it. SolidCAM let it copy over all the internal data that SolidCAM stores in your solid part file. And now, well, do you want to open all that stuff that's been copied into the -4? And oh yeah, now it's okay, open it. Sometimes it prompts me like this, sometimes it doesn't. Close the original document. Yes. So now let's go see if it did it. Yes, there's only one document open, it's the -4. I also often like to come up here, you got to shake it a little. When I work on this on my 4, I got a 4 monitor setup, right? This thing is sweet. So, and that's some of the video problems I had sorting out. But when I work on it, normally SolidWorks is stretched out over at least 2 monitors. So you can read all this stuff up here. Look at, this is a little minor form of abuse. Look at what Enable Command Manager. SolidCAM takes over your command, puts this tab, this tab, this tab, this tab, this tab, this. Well, that is kind of rude, but it might help you understanding what they intend you to do. But one problem is it makes the dialog boxes that appear in this panel smaller. So the other issue, MasterCAM does this, always pushing because of these long names here, some of them that I don't control, they created this thing. So you either use your Logitech mouse with a rocking scroll wheel for left-right scroll, or you go down here. MasterCAM didn't even give me that might be a video artifact though. I'll have to install MasterCAM. I upgraded to Windows 10 to try to solve any incompatibility. SolidWorks isn't going to even support Windows 10 next year. So here we are, and here's all that stuff we did last 3 shows, right? There's all the tool paths. Some of them are goofy, like why when it did the slopes, it pulls up so high. All that you can fix. That's clerical work. I'm not too worried about that. It's the overall flow and stuff. So now we flipped it over and we're working on the bottom. And what happens if I go down here? Does it show me? That's a little concerning that it doesn't show me now this bottom setup. The origin isn't here. The origin is right there. But let's see what happens. So we did the, oh, here's a mistake, updated stock. See, it gives you the funniest names, and you can't change them in the tree itself. You got to go here and say face bottom. Enter doesn't do anything. Here, you got to know, can you see that? Probably not under my headshot. Now you got, and this is one of the exasperations, nothing's labeled down here. If you use it every day, it's not a problem. I'm an intermittent user doing prototype work. It always gives this little goofy coordinates, this up level. I should dismiss it, but I'm afraid. Okay, so here we are. Now all we have to do to finish this part is these 5 holes. So let me show you how I spent a little quality time. See, it's moved the tree again. Let's collapse it so it's a little less clumsy. Here, this is one of those dialogues, like the add-in dialogue or the tools dialogue when SolidWorks is running. It goes all the way off the screen in a little tiny triangle at the bottom. The scroll wheel doesn't work in these. It's very exhausting. And that's a SolidWorks problem. It has nothing to do with SolidCAM. Add milling operation. Well, I saw, where was it? Recognized. Drill recognition. I'm like, I'm all for automatic stuff. It hasn't worked in any of the programs. Nothing automatic. And of course, this part has been designed to trip up all this automatic feature recognition. It tripped it up in all 5 programs. So here, let's see. Once again, it's like, well, what do you do? Where do you start? Well, you got to know this little gray on gray Steve Jobs approved button. I'm sure a young fellow designed this who grew up with smartphones. And that's why I have so much trouble with it, because I'm not a smartphone user. Does its thing. It thinks you're allowed to name stuff. You know me, I'm big on naming it. Let's do holes. These are the holes. Oh, and we're going to select holes. This might seem silly, but you'll see why I'm doing it. Holes clockwise. I'm going to select them in a clockwise way to show you something MasterCAM can't do that these guys do. Now, where is it? When you say automatic, it gives you all these filtering kind of things. What is a diameter, biggest, smallest, upper level, all these things. This is all in one face. I think Visual Mill just lets it pick that face. Any holes on there? That's I'm interested in doing. Find holes. Well, I'm all for that. Find them. So then, like all of them, it kind of screws up. It screws up in multiple ways. It's got 5 operations. It might be hard for you folks to see, but follow along. This first one is this hole. Second one, just see it turning blue a little. This one here. Third hole, this one here. Shape 2. And see, this is because even though all the holes are identical, 0.38 deep in SolidWorks on purpose. My buddy did it this way, Dave. Some of them break out, some of them go through. Some of them partially break out. And that's what's tripping up all these cam things. So, okay, there's 3. Then you go here. That's these 2. And I think those are the through holes. Is it? No, those are the blinds. So then it groups the 2 blinds. And then, for some crazy reason, it reselects this partial one. And I think that's because, well, partially it's through and partially it's blind. So let's count it twice. So there's actually 2 operations. This one down here. I believe this one up here. See, they're both lit up. All right. So it screwed that up, but, and you know, there's all those selection criteria. To me, it's not automatic if I got to spend a half an hour teaching this thing for this particular instance. It's just easier to pick the 5 holes. Might not be true if you got 100, but for me, prototype work, yeah. So I found the holes. I've named them right. It's given me a green arrow. We'll say yes. Okay, the tool. I went through this select. All it shows is the 1/4 inch end mill we've used to do this whole part. That's by design intent. Dave designed it to use 1 end mill. You have to understand, don't hit the green thing, or no, green thing will just let you design your own tool. You want to go to this one, unlabeled, import tools. Up it comes, and look how sweet. And of course, like everything, it's, I think every software engineer must love being a surgeon doing orthoscopic surgery with a hole this big. Everything's smashed in. What do we want to find? CL. CL, that's the length. We want AD. Where is AD? Can we see it? No. Oh, scroll down here. Where's AD? No, we're way too far. Here it is. Okay. Since we have 1/4 inch collet in there for let's keep the 1/4 inch shank mill here. So that's number 3. So how's it work? You are happy now, and oh, okay, more trickery. This is, I think maybe with an 8.5, 11 sheet to remind me if I haven't done it in a month. Okay, here are where you start on things. Here's the unlabeled buttons. Remember to do this. It won't be that hard. Don't go to the green one. Go to this one. Don't just click it. Click this and say, no, I want this to have the next tool number 2 in my part, not tool number 3 that it happens to be in this table. Next free tool number. It's done that. I used to bother you. It didn't tell you it did it. But if this was on a different monitor, like it would be normally when I use it, I would have seen the tool appear in this table. So it's only because I'm making a video that makes it a little confusing. Also confusing that you got to go over here to this little red thing and say dismiss it. Now it's got the right tool. I think, see, this is what's fantastic. See how it highlights when you're in, oh, that's a total tool length. We'll see this when we get to the tap. I'll play around a little with the tap. All right, this is cool. Let's just leave it. It's close enough. See, I use this every day for a week and I'm confused again. Are we done? Yes, we just do the green arrow now down in the bottom corner, if you could see it down here. Okay, so now it's got that tool, center drill. This operation, the geometry was holes clockwise, picked clockwise, but I want it center drill, and I don't like capitalized holes, clockwise. So now we got a name, we got the tool, levels. Okay, this is where it screws up. Depth edit. You say depth edit, it gets you back here. It says 0.25, but it does different for some reason. Let's get out of this. Leave the depth, technology, blah, blah, blah. I think we're okay. I think we're ready to go. Okay, so we'll come over here so you can see the toolpaths appear. We'll hit the mystery 3rd button, save and calculate, same as regenerate, same as generate in BobCAD. There it goes. There's your things. Now it's showing the part 0 where it should be down here in the corner. That's reassuring. That's good. I think we're ready to go. Now we can do the simulate. If you can see it, it's all this moving dialogues around is only because I've got to compress this into one video that you folks can see. Usually on 4 screens, it's wonderful working with this thing. This button, you got to understand, unlabeled, of course. Simulate. Go here. Oh, okay. And it doesn't, see how it buried one and didn't bury the other? And even on this low budget simulator, you can see it's going way deep. It would break that tool because there's not any relief in a center drill that deep. This one, it does almost right, maybe a little deep, right? So they're all different. And if you don't believe me, we can close this. We'll save out of this and close. And we'll use the fantastic Simulator Fantastico SolidWorks simulator in beta. Comes, shows you the correct stock condition. How was I going to put it in the vise? Let's get in that habit while we're here. We're going to put it in the vise like this. This is why part 0 is back in this corner. And then slow it way down, and let's turn off the pretty. That was the compare function, right? It's green because everything's where it's supposed to be. Do it. See? And you can almost see because I use this translucent stock. Oh, and you notice it hit that hole twice because it counted it twice. Automatic. And like Mastercam did the same thing. It did this one hole pretty shallow and it buried the others. So there's some software algorithm that decides how to treat blind and through and partially through. But in general, they're all way too deep. Let's see if we can fix it. In my rehearsals, I didn't go this far. I just gave up on it because I got disgusted. But let's see if we can do it this way. Levels, depth edit, drill depth, all. And let's go 0.2. Apply. Say, okay, it's asked us to do something. Hopefully it should regenerate now. It did. And let's just get out of this because I like that other simulator so good. How are we doing? 15 minutes. We'll get this done. Hang on. 5 holes, half an hour. Normal novice productivity. And uncheck the toolpaths and simulate beta. Constantly flips it around. I don't know. They're cruel. Ah, so that did fix it. So actually, all it did was really locate it for us because we're going to be fighting these depths with every operation. And unlike, I think it was Bobcat, you say, I want a tapped hole, it'll do the center drill, the drill, a chamfer, and a tap. And it kind of got shuffled around, but it lets you drag them all together. So it does 5 center drills. That's, you know, for the inexpensive program, that certainly was impressive. So what I'm going to do, just because I'm a manual transmission guy, I guess, hit the delete key. Do you want to really delete this? Yes. Then we're going to go back and do the way I rehearsed it, just so we don't have any surprises. And now just say drilling. Oh, that's why it had, I called it holes clockwise. Did it keep that? No, I guess it didn't because I deleted. Now we're going to select geometry. You got to know the mystery buttons where you want to go. Instead of drill, we're going to call this holes selected clockwise. Now we're going to find out how this thing acts. I learned in one of these CAM programs, if you select the whole side of the hole here, that gives it some depth information, and then it starts splitting stuff up. Well, this is deeper than this, even though they're not. Select the edge, and we're going to select them in a clockwise fashion. And you see them appearing over here. That's comforting, right? Just select the edge so it doesn't have any depth information. I don't think it will anyway. So as the part sits in the vise, we've selected them clockwise. We say OK. Geometry already exists. Wait a minute. I got to get out of this because I started editing. Current cannot be interpreted. X. What did I do? I was in the face. See, this is how I get turned around. All right, hopefully I haven't damaged anything. Is face still okay? Yeah. I thought I did this right. It'd be interesting to watch the video, see what happened. I thought I said add milling operation, not drill recognition, just plain old drilling. Here. Okay. Say 2D drill, hit it, say holes dash clockwise, just in case that has got some trash DNA screwing it up. Here, here, here. Now it's kind of acting, see, how do I undo that? Delete. Yes, delete it. Now do this one. See, I selected the side, and that is not a good thing to do. So I selected the holes clockwise. We'll see how this works. Here, tool. Since we already played with that tool, it should be in there. That center drill, it's here. Okay, so that's good. Save us a little time. Levels, see, it doesn't know what to do. The upper level is 1 inch above part 0. I know that for a fact. The drill depth is 1 inch. It wants to drive this thing 1 inch down. I guess say, well, we might as well go all the way down to part plane 0. I know I want to go, I think 0.2 works out pretty good. That's what I tried the other day. I can pull this off a little and you can see when I hit the mystery third button, it should think, there we go. And there they are. And now we'll, like I say, I like that other simulator so much. Turn off the tool paths and say SolidCAM simulator, SolidCAM, yes. Flip it around. Notice it's got a nice, this is the beautiful thing. The taps have taper on the tips. It's fantastic, the job they did on this. Do this, bing, 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 bing. There you go, perfect. And you do the compare, and this is, see, this is why I love this simulator. What's this telling us? Yellow. Okay, yellow means it's a little towards the gouge side, but it's gouged relative to the 0.201 tap drill size. This isn't gouged to the 1/4 tap necessarily. It says it's just starting. So I look at it like a free chamfer operation, and I don't think it's deep enough that it's going to cause chip evacuation problems or anything else. So I like 0.2. And this is what I love about this simulator. It helps you make these kind of decisions before you get out to the mill. So I didn't name it right. So this is center drill. Picked them clockwise. And it did them clockwise, right? And I think we just save out of this. So then once again, now you can do a Control C, Control V, you can copy this here. You don't have to exit saying copy it. I'm just as soon let's do stuff individually. We got time. We're going to have plenty of time. Do another drilling operation. We're going to do it now. Geometry, sorry. Does it let us choose that other one? Yeah, if you see now, here's another way to use the previous geometry. Just pick it here, right? A lot of ways to do the same thing in programs. But now, instead of picking them around this direction, it's sitting like it will in the vise. And my theory was I'd like to watch the operation up closer to me. Here's the fixed jaw device at the back. Here's closer to me. Let's have it start close to me so I can kind of be eyeballing it. But now we're going to select counterclockwise. 1, 2, 3. Oh, oops. Yes. There, that's what I want. Here, I'm glad this mistake happened. The name will be holes dash clockwise, just to keep it. And I think we're all ready. Go here. Geometry already exists. Holes CW test. Let's see if that has anything to do with it. Apparently the strings, and it's got remembered strings somewhere, evil. Okay, fine. Now we want to do select a tool. We know to go import over here. Will I remember this in a month? Probably not. And I got to gig brag this so you folks can see it. Here it is. It's not center drills anymore. I think I did general. And it had down here. Here we go. Drills. Number 49, we want bigger. Going down is bigger. Yes, we got to get to a number 7. I just happen to know. Here it is. Should see the 201. There it is. That's tap drill. Happen to know. They don't help you, right? Well, some of the programs do seem to. If you tell it quarter 20 tap, they know to pick a 201. But the beautiful thing when we do pick the tap in this program, they have tools in their canned tool selection to roll the taps. And you don't use this size tap drill then. You use a number 1, I think, tap drill. So you got that. You got to remember to go here and say next free tool number. It did it. And if we were uncovered, I should have done that. So you could see it appears here. Life is good. You then can go this right arrow, I think. Yeah, get out. See, now everything's a little different. Every dialog box, in and out, it's kind of different. The tool is selected now. The green checkbox to get out. There's our tool. Is 201 somewhere? I didn't look to see it's 118. Visual Mill does 120. You got to go edit that and make it 118 if you want it to really look perfect in the simulator. Levels. Once again, starts an inch up. That's correct. Goes an inch down. That's incorrect. 0.0. I think this is savage that you got, that it just doesn't pick up the data from SolidWorks. 0.38 is the way the whole wizard in SolidWorks defines it. But when they do that kind of thing, they go to the tip of the drill, 0.38, not the way SolidWorks defines holes, which is the cylindrical part of the drill, the flank, the corner, however you want to call it, going down, 0.38. The actual depth of the tip of the drill with its 118 degree angle is 0.44. More human misery, technology. Oh, once again, drill cycle type. I buy this program so I don't have to learn G codes, but thankfully, they use the word peck here. That's the only indication. I assume it'll peck. I don't know. Everybody else just says, well, you want a peck drill? You say, yeah. Okay. What do we do next? See, there's everything you do is a little different to get you turned around. I think we're ready to do that. There they are. And say, well, we've got this one up. Let's do the poor man simulator. And let's see if it does go counterclockwise. Yeah. Now, this is a big deal. But notice, the tool never seems to touch the part. The tap acts this way too. It's pretty exasperating. Close this. We get our dialog box back. I'll pull it up so you folks can see it. Normally, I just keep it on one of the other screens. I always save and exit here because I'm paranoid. Turn the tool pass off. Shrink it back down. Right click it. SolidCAM Simulator Beta. Turn off the compare function. tell it to do its thing. This one, see, for my money, that's really worth a lot. So, okay, now it seems, doing the 0.44, and you'll see why I did that. You notice the bottom of the blind holes are green. This is within 1/1000th of an inch, 0.44. And I learned this doing all these other programs that do things wrong. Either they pick up the 0.38 from SolidWorks, and they don't use the SolidWorks Hole Wizard data. They just kind of measure something and decide, and then do the wrong thing. So, like I say, automatic, electronics had this automatic for laying out circuit boards. Never worked. Maybe if you pay 50 grand for Allegro, it might get something. But like, you got to train it. You got to make sure it's a special case. So good. Now we've got confident. And now this is what's going to be great. This is what I love. Let's go up. What can we do? How do we do this? If we go here, highlight them both, right click and say simulate. Well, it should show us the tap drill. Oh gosh, you got to love this. So as a newbie, the simulator is much more important to me than I'm sure a lot of you experts. Sure enough, it goes clockwise. Mastercam doesn't. There's all this goofiness about how to change the order and rearranging, and it's crazy. This one is just you pick them in this order. That's how we'll shoot the holes. I love that. A little non-artificial intelligence. And then highlight both, have the simulator work on both. Obviously, if you go way up, you can watch it. We'll do that at the end. We got just enough time. 27 minutes. Race against time. Where is it? Add milling operations. I think you go back to drilling. This time, we'll just pick up our holes clockwise test. Our tool will now be select. Do I have this? No, I don't. Tool table import. You got to remember it's third button on the left. It looks like this and it's kind of green. Do they have taps in here? I practiced this. I do not see taps. So then you just go up here and instead of the general can thing or the getting started, I think master for aluminum, you get even more tools. And somewhere down here we'll get to taps. There we are. 1032, quarter 20. Notice, and this is a real cool thing that they bother, that they, software make sure they don't do any tedium, but they push it onto us. In this case, the programmers have done some tedious work. They've put all these tools in. Of course, you can never read it because of the orthoscopic, nothing can be readable. But here you go. Quarter 20, quarter 20, quarter 20. You can just barely see cutter length over here. Can we collapse this down? Not really. The three are increasing cutter length. And of course, the shorter the tapping part is, the stronger the tap, the less it'll break. Then form. Look at this. Form tap. That's what we call roll threads, where it just squeezes the metal. It doesn't leave any chips. That's a different thing. We're not going to do that. We didn't have this option in other programs. And then I'm not sure what an STI cut. This quarter 28 is fine thread. So we're just going to go to the shortest quarter 20 right here. Tool number 655. Quarter inch, quarter 20. Remember to do this. Remember to say the next free tool number. Remember to go over here and close it. And there it is. It's our tool 1234. So it'll be T04 in the G code, which is cool. I can't. My Avid Benchtop Pro, it won't do rigid tapping. There's no encoder on the spindle. But I figured it might interest everybody, so let's go through with this. I just leave this tapping operation off. Description, quarter 20 cut tab. That's actually good to have, isn't it? But quarter 20 tap, high speed, I don't care about that. Quarter 20 tap. And you know me, I'm a professional writer. I don't like too many capitals. It's hard to read. Now watch. Here's some of the beauty of it. You can edit this tap right now if you want. It's stored inside the part file. Or if you make an external, it'll be in that PRZ file. And I love, you highlight it and it yellows up the things that is going to change. But notice this CL right here. That's the taper, a plug tap, a bottoming tap, a normal tap. That kind of represents that. Watch how cool this is. I think we're ready. We gave a geometry. Oh, this is just a tool selection. Then I'm pretty sure levels. See, it wants to go an inch down. We know better. Let's go 0.42 because we are rightly worried about bottoming this tap into the hole and breaking it off. So instead of 44 thousandths, we'll go 42 because everybody in CAM seems to measure from the tip of the tool. Technology, I got really worried. G84. What's G84? Is this going to reverse on the way up because it has a tap? It seems a little smart because now it only gives you two choices. And pecking a tap, you know, I'm not quite sure. I guess it would reverse. And hopefully, one of the problems with all these simulators, they don't show you the rotation of the spindle. This is why you got to rehearse everything, give an audition above in air before you actually start cutting chips. I think we're ready. We'll go over here, do its thing. We'll close it. Oh, I didn't name it right. Hang on. I'm going to be proper. You think this is silly, but it's not. Drill holes, close, tap holes. Enter doesn't do anything, but I love that because they leave the dialog box up. Save. There it is. Now we'll get going. We're running a little bit long, but there's a payoff here. So now there's the tap. You notice, unlike many other programs, they model the taper there. Bobcat has this thing, I think it's Bobcat, has a thing about effective number of threads. And that's how you kind of fool it. But I don't think it models the taper like these folks. 1, 2, 3, 4, 5. And I'm pretty sure it's honoring what we selected as clockwise, counterclockwise for geometry. I'm almost positive. Now here's what this simulator does for me, why I think it's so fantastic. I have such trouble with SolidWorks. Okay, we want to look at this hole right here. This is the hole, and notice how they got a little green shading, and you can almost see, let's see if I can get close enough, see that green shading stops prior to here, and it's a little tricky because it's breaking out. You see these little angles. But this point here, see it lit up? That I think is the corner of the drill, the 201 drill. So this says, oh, we're not bottoming that tap. And then if you turn on colors, it's even more obvious. And the cool thing is it's showing you 201 is the way it's modeled, so it's green. This says, oh, yeah, it's red because the tap is modeled as 1/4 of an inch. So it's really, the program has to consider that a gouge because the solid model is 0.201. That should be. But as it narrows down, you see it turns yellow because it's less of a gouge, and then it turns green because it hasn't affected that. And I'll get out of here. You can go and model. Look at what's it thinking. I don't know. You can go here in the tool, select, and you can go here in this chamfer length. You can cut it in half. Say, you won't see that. Hang on. Say yes. And say, I don't think you even have to. Operations, no. Save and exit. There we go. Nice that they tell. Oh, and it hasn't regenerated. All right. Calculate. Okay, good. There it is. Now we'll do our SolidCAM simulator beta. Go real quick. 1, 2, 3, 4. Don't worry that they're red, and you will see that that taper is a little, oh, it's hard to see. It's a little blunter. It actually models that. To me, what's that worth? That's fantastic, right? So this simulator is a big win for in my book. Okay, if you want, you can come up here and SolidCAM simulator beta. And let's speed it way up reasonably. Have we turned off compare? No, now we turn off compare. And you can watch. We're finished. Sorry, we're running late. We're 5 minutes late. That's life. Here it is. And I think the compare, you can turn it on at any time you want. Yeah. But it has those artifacts I pointed out in the last show. And showed how to kind of get rid of it. Not. There's that. Here it's doing the slopes. With those, watch these tall pull-ups it does. It's kind of crazy. Does here. Now it's going to go to the bottom. It's doing that. Climb milling, going in a circle inside, which doesn't leave a burr as it finishes off. Bam, bam, bam. Pretty cool. So, that's it. Once again, if you just quit this file, SolidCAM is going to save it. whether it's not going to ask you. It will save the file, which is kind of a benefit. You don't lose work, but none of these CAM programs are able to undo, because they're kind of this add-on onto SolidWorks. If you say undo, sometimes it go undo the last thing you did in SolidWorks. But anyway, that's SolidCAM, fourth impression. We made the part. Now I'm going to start looking at fixturing and, working in an assembly. Does that make sense? Have some more thoughts about having this external. Only SolidCAM lets you make this external file that links to your original file, but is inside a zip now, a PRZ, so that your CAM, your what do you call it? Your product lifetime maintenance, PLM, life cycle, won't get confused because there's two files with the same name. So all the clever stuff they're doing at SolidCAM. Meanwhile, I'll get the other programs installed on this Win 10 version. We'll start playing around some more and have a little more suffering with software. Help you decide what CAM package is right for you. Catch you next time.